And welcome to this video. We're going to just look at using Open Daylight as an SDN controller. I'm using the Beryllium release, and I'm going to be looking at OVSDB Manager, so the Open Virtual Switch Database Manager or management, and that's going to be the management of two remote OVS switches. And between those two OVS switches, I'm going to set up an Ethernet virtual circuit, an EVC. So just to go through the setup, we've got a few machines that are sort of hosting the necessary beasts as part of this video and demonstration. Starting off with Postman, I'm using Postman over a restful interface into an Open Daylight SDN controller. That's hosting on another machine, or a remote machine. That machine is at 192.168.1.220. And we can also see made mention here of the OVSDB Manager, which is on the same IP address, but using port number 6640. So I have two remote switches. Well, one in fact is actually resident on the same node as the SDN controller, so that's at 220. But the other is on another machine, which is at 192.168.1.225. That's OVS switch number 1. So what I have to do is I have to point both of those through appropriate OVS commands back through to the manager at the SDN controller. So that's exactly what I do. So we'll see the commands that are used to do that. At the moment it's up and running, all of the config is there. So I'll have a look around, look at the config, and then we'll start tearing it down so as to remove the OVSDB management connections to the remote switches, and indeed remove the endpoints and remove the EVC itself. So there's a few of those commands that we're going to be using that are listed down below, and perhaps we'll use a few more besides. So let's have a look as we go through. So as we can see, I've actually got a Mininet VM running. This is actually running in Oracle VirtualBox, as we can see behind. That's on the local machine, and then I'm remotely connecting in using PuTTY to another machine, a second machine, and we can see that indeed there is an OVSDB bridge, or an OVS bridge, and then what we've also got is Ethernet 0, and that's at 192.168.1.220. So if we do the same sort of thing over here, we should see that Ethernet 0 is indeed our 192.168.1.225. Make a note of the MAC addresses, or at least the ending of them. They're both on virtual machines as it happens, so they start 080027, and then we start to see some variation after the 080027. So 5C35F0 and 01548E. So those are the two MAC addresses which we'll be using as the two endpoints. So just to remind ourselves where we are, we've got our virtual machine here running as 225, and we've got our second one which is going to be supporting the other OVS switch on the other end. So if we have a look, a very simple sort of command to start off with, so sudo OVS virtual switch control, or vsctl, and show. And we can see that we've currently got an OVS bridge that's been established. Let's have a look at the other end. Let's do the same sort of thing. So sudo ovs-vsctl and show. Put in the right password. And there we have our OVS bridge. Now, this is looking a little bit incomplete, so we'll have a look and see what's different. We can see there's a GRE tunnel on the left-hand side, not mentioned on the right-hand side, so not quite as complete. But we can see that there's still an OVS bridge that's been established. And we can also see the OVS version as well. They are different, it will work. I've seen some recommendations out there that say that we probably need a higher release on the left-hand machine, but as you can see, it will work. And we can see the manager that they're pointing to. They're pointing to the same manager. Indeed they are, to 220.6640 as the port number. This is an important value here, because if you're trying to track down at the controlling end commands associated OVSDB style with a particular switch, then this happens to be their OVSDB ID. There's other commands that we could use, not least one that's actually was printed on the earlier diagram, and that referred to the opportunity to list the open capitalize the open, and make sure you've done that, of course, vswitch. And we can see in here there's a whole set of IDs that are associated with that particular device, as well as the actual system that it's running on, the OVS version manager, as we can see in here as an option. And if we compare that with the show, we can see the value in here is the OVSDB ID, which ends in 567. And if we scroll up, we can see it's this user-to-user ID here that ends in 567. There it is. So that, in the list command, is indeed the OVSDB ID, but it's as easy, if not easier, to see it here. Make a note of the number, make a note of the end there, and if we have a look at another command which you would suppose would have that information, and that's the ovs-vsctl list manager command. And in here we've got an ID, a user-to-user ID, but it's not the OVSDB ID. And again, if you're looking for messages up at the SDN controller associated with this, so you want to see that they've actually started to talk to each other. You know, we've probably got a problem. We're trying to debug. The value that you're looking for shows up more clearly when we simply do an OVS show, and that's what that value is. Okay, so if you're doing open daylight as I am, then what you would do is you go and look in within the distribution. So then you drill down and you'd look at the data and the log directories, and in the log directory you would find there is a caraf log. If you tail that, so tail minus F, for instance, and then the caraf log, as things start up, as things start to talk to each other, you should be able to see then the OVSDB connection forming, and you should see that OVSDB ID. Okay, so that's just some element of debugging so far. So it's not quite complete. So we'll have a look and see what's not complete within the configuration itself, and we'll use Postman in order to do that. So here is Postman. Now I let Postman set up because I've got it online, so therefore it will actually give me all of the Postman collections that I've got on my machines. So against this particular account I've got this set of Postman collections, and within the Postman collection there's a whole set of commands that I would use restful style. So I can see on the right hand side is the construct of that command, or those commands, but I've actually saved those over here. So I could do a simple topology get. Now you always have to make sure that you're actually talking to the correct controller. So I would save these against different controllers, as I have. There's one a little bit further down that will do this for me. And as it's a get command, so a get method, as in the sort of restful nature of the interface, so we're trying to get information, then it's very unlikely I need any body parts to this, other than I need some authorization. So I'm not using any certificates, although I would be normally. I'm just using basic username and password, and that's the default username and password of admin that you would have associated with the actual ODL or SDN control itself. So Open Daylight, that's its default login credentials. If I send that, I'm looking for a 200 OK, which would tell me I'm probably talking to the correct machine. And then what I'd see is some element of topology. So there's some netconf stuff in here, which we'll use at a different time. It's trying, it's identified as part of the config here, a Cisco device. It hasn't identified that by magic. I put that in on another lab. And we've also got here, as a result of building up some of the features, that it's got some controller connections in here in the shape of port 2830. And also in support of netconf, I'd expect to see 1830 as well. So 830, 1830 and 2830, when you'd normally associate those with the likes of netconf. So we'll do that on another day. We're interested in the OVSDB stuff, which starts with OVSDB and then an integer number. So this is a set of information, an instance, if you like, of OVSDB. So as I scroll down here, I can start to pick out sort of OVS IDs. Look, 5, 6, 7. that's the user to user. Now it actually starts forward slash, and then you've got that UUID and so on. So sometimes you have to encode that forward slash, and you'll see that a little bit later. I'll show you how that's coded in. And what we can see then is we can see there's information here concerning a connection through to 225.6640, so that's the remote machine as far as the SDN controller is, because that's the mininet one, and the 220. So these two are connected, and indeed they were, if you remember, as part of the OVS show. So if we pull up the mininet and we have a look, we can see it says the manager is 192.168.1.220.6640 is connected, true. So we've got a connection to that. We can see that in here. I got some Q and quas information. I'm scrolling down because I want to come down and find there's another node, which would be the other end, and the quas and Q entries for that. So that's the two known devices. Again, we're coming down through. We've got other information in here. Keep that going. Here we go. This is termination points. This is associated with a particular GRE tunnel. So we can see that there's certainly one end is mentioned, but not the other. So there's only one side that's got GRE configuration. That's the 220 side. The 225 did not. Or did it? We'll have to check, in fact. See if that's telling us the truth. And then we've got this. This is where I was going towards, the Uni Manager. So you'll have to install this as a feature in order to be able to do this. So this is an ODL feature install, and your feature install is ODL-Uni Manager. If you're not sure, then we can look for that. We'll have a look. You can see where that is in the feature set and see if it's actually been installed. And then what we'll find underneath this is we've got information concerning a particular node. We can see the node endpoint. We can see the type of connectivity as being full duplex and the like. We'll come back to this in a moment. And then we can see the other end of the connection here. But the sort of EVC stuff was sort of one-ended. It's not built correctly by the looks of things. So I need to find the EVC, the correct connection there, and we'll have a little bit of a play with that. So the set of commands that I've got available to me, and bearing in mind what I've done here, is would have put a connection in between the two devices. So this is the put command. It would require authentication, and the body part here would describe the EVC number as an integer number, and then the two endpoints. So we can see 220 and 225. So it'll also talk about the actual bandwidth required for this connection, which we can see is identified as 10 megabits per second. So this would be the EVC, and I would put it on the particular Open Daylight SDN controller using the restful interface, so it's restconf. It's going to be part of the configuration, and it's against the Uni Manager, and it's creating an EVC link, and the EVC link is of type, well, of an ID EVC : // which is this %2f that we can see here. So the %2f is the critical part. %2f, and then a 1. And that corresponds to / / 1. So there seems to be an element that's in there. So what I'm going to do is tidy up a little bit. And what I'm going to do is I'm going to try and take away the two endpoints. And I'm also going to take away that OVSDB one as well. So if I think about the two endpoints themselves, then I'm going to delete those. So the method is delete. It's again is off to that particular controller. Now the endpoint that I'm aiming at is // so it's a uni, as a user network interface on // 192.168.1.225. Authentication wise, let's put the basic authentication on there and send that. See if we get the 200 OK back. Make sure we sent it to the correct device. There we are, 200 OK coming back. And I'm going to delete the other end. So the other end was in fact the 220. So let's see if that will do that for me. Let's have a look. And oh no, it's a 218 at the end. So let's change that to 220. Make sure it's set correctly. So it was in fact 192.168.1.220, and somehow I managed to get rid of the colon. Very clever. And then we'll get into the basic authentication again. So we'll make sure it's going to the right place. Seems to be okay. It's going against OVSDB 1. So let's have a look, see what's missing here in terms of what we're trying to delete. So we're trying to delete something. What it's saying is data does not exist for that particular path. So this is looking at 192.168.1.220.6640. So it seems to be incomplete. So let's use the other example that worked. And what we can see is that this indeed worked 225, and it seems to suggest that the other information is not there. So let's do a get topology just to prove that it is there or not. Scroll down. That seems to be where the information resides. And what we can see here is, first of all, it thinks the EVC is still there, even though it was only showing up as one-ended before. So we'll need to remove that first before we can remove the endpoints satisfactorily. So one of the endpoints is gone, but the other endpoint is still here, the 220. So I'm going to remove the EVC sort of end to end. So all I need to do is pick out from my appropriate deletes that I've got the one that will take away the EVC itself. So we could do where we've got the EVC between the endpoints as the put, and without going into the detail just yet, we'll come back and have a look at that. Come on, Beastie, do your stuff. That's it, that's better. So you can certainly see that's between the two endpoints, and more importantly, it's this integer value here. That's the only value I really need, in fact, is that value. So I don't need the body part in the delete message. So I can go into delete, I can save this, we'll save as. So what we're doing here is we're going in this case, we're going to delete the EVC between the endpoints, between A and B 220. I'll put it into the EVC folder, so we'll save that. Let's get rid of that body part just to prove the point. Okay, so there's no body to this. There is authorization. There is no body, and we're going to go against that integer value at //1, hence the %2f for that particular beastie. So I'll save that against that name, because I've changed it, and send it. 200 OK. So if I look at the topology again, and it goes down to the same place as where I was before, what you should see then is, once I send it, apologies, send it, then what you should see is I've got the EVC mentioned here. There's nothing against it. It moves it to the bottom. And then we've got the Uni Manager, where it's only got the one interface, which is the 220. Yep, so the 220 is the node I want to talk to, and the interface I want to talk about is 220 as it happens. But it could be a different interface, of course, on a multi-interface device. So we still need to remove that. That end, if you like, was put using this. So this would be the put with the right authorization. If I now delete it, so I'll save that as a delete. In that collection. Make sure the authentication is on, correct, send, wait for the 200 OK, check the topology, send, so that it makes the new request, and we can now see that there are no endpoints and there's no virtual circuit in between. Okay, so let's just go back to the devices themselves. In fact, one more thing that we could do here is all of this is associated with OVSDB number 1. So we could actually remove that in its entirety as a config. So if I go back up through my Postman collection, I've actually done this in the past. So all I need to do is find the correct one. There's a delete look. Delete OVS node entry. Just make sure it's going to the right machine, 220. Make sure we've got the right authentication on. So admin. It's the OVSDB number 1. That's where we're targeting. And if we send that, look for the 200 OK. If you send it again, it should come back as 4040 unfound because of course you've deleted it. So if we go back down and find the topology, so get network topology and send that, again we've pretty much lost it. We're back to netconf and stuff. Okay, so what has that done to the endpoints themselves? So if we look at the mininet node first, repeat the show command, we can see that it's still connected to the manager, at least, but there's no configuration there because it's been removed. Remember, there was GRE configuration here before, if we look a little bit higher up. And if we look at the PuTTY connection as well, and we do the same sort of thing, if we clear the screen first just to tidy things up, whoops, and do that again, we can see again it's still connected. So first things first, we can bring up Wireshark, and we can see that if we start Wireshark, this is running on the local, this is running on the machine which is the laptop hosting 225. So it's the one that's hosting the Mininet VM. We can see that we have indeed got some 6640 traffic going, because that's the only stuff that I think I've captured on this capture filter. So if we have a look at one of these, if we open up that packet, what we can actually see, of course, is the TCP port number and the TCP port number 6640. So there is traffic going backwards and forwards. Right, let's, we're on the remote machine, so let's use the Mininet one instead. And what we can do here is, using ovs-vsctl commands, is we can delete the manager. And just to prove that's done, so we can now see that it's not. And if we modify this command to list manager again, we can see there's no manager listed. Right, if we stop or restart, of course, would be the option. So restart that, there's no traffic. So this is the remote connection going back up to the manager, and we can do exactly the same thing up here, where at the moment we've got a manager, and again we can actually remove that manager just by using the delete-manager command, OVSKettle style. Good. So at this moment in time then, it doesn't have a manager connection, but we can still see it has an OVSDB ID and it has a version number. So there's nothing on that switch, and there's nothing in the configuration on our controller other than the netconf stuff that we had before. All of the sort of EVC stuff down here is now drawing a blank. So first things first is, of course, we need to create that connection to the manager. So it's a sudo ovs-vsctl set manager command. We're going to use TCP. You can use passive TCP, but this is one I prefer. 192.168.1.220. 6640 is the correct port number. So hopefully that's done its job. So at the moment it might not be connected. So what we could do is do a list manager, and this will actually show the state at which it's at. Now it's actually gone to active. Now you could actually find that it's trying to make the connection, so it's not moved into this active state, so it could be in a connecting state, in which case, or any one of a number of other states, in which case there might be a connection issue. It might just be a case of just wait a little while and it will form that connection. Shouldn't take too long, but there could be some network connectivity issues, or you don't have the correct features installed on Open Daylight. So on the other side is we've got the Mininet connection, and the Mininet connection we need to do exactly the same. So ovs-vsctl, and we're going to do a set manager, and we're going to do that TCP style 192.168.1.220, of course, because that's where the controller is. So they're both pointing to the same manager. And if we do a list, it's a bit quick. If we do a list, there it is. It's moved into an active state. And if we do a show, we can see that the manager is indeed connected. But again, there's no further configuration. If we go to Postman, if we look at the topology again and send that, we can see it's just the netconf stuff that's still in play. So we have connectivity, do we? Well, as far as Wireshark is concerned, there's activity taking place in the background. In fact, we just stop that and then start that again. We can see just by stopping and starting it, then there's periodically information going from 225 to 220. Yeah, and that's the nature of the beast at the moment. So let's have a look then at Postman again. So what we need to do is we need, on the Uni Manager side, we need to set up the user network interfaces. So we need to put the endpoints. We have the endpoint Postman collection here, so it's a put. It's against the SDN controller and the restful interface. It's topology, but it's topology against the Uni Manager Uni, and the Uni interface. So this is its ID, is uni-//192.168.1.225. Authorization we need, admin and the body part now. So the body part is, this is the node that we're going to talk to. This is the remote node, the remote to the manager, that is. And indeed this is, because it's on 225. The speed of the interface, and then its type. So it's a Ethernet type, and against the Ethernet variety, of course. We've got the type of interface described, so we can see that this is a full duplex connection. The MTU size is not described here, but it could be, and the unit type. But I've gone for the MAC address, which you'll have to change. That has to be as per the interface, as we saw right at the start. And then we can see the IP address and the fact we're setting up as full duplex. There are other parameters that we could set, but this is a good basic set to begin with. So all being well, assuming we've got the same ID here as we've got up here, these have to correlate, that and that, because that's basically the record that we're writing, and this down here is the actual interface specification. So let's send that. Look out for the 200 OK. 200 OK is fine. Quick topology check. Send that. And we've just opened up an entry, look, a 100 megabit connection entry under Uni Manager. Nothing under EVC yet. That's fine. So we've put the far end. So if that's the case, if we go and have a look on Mininet and do the show ovs-vsctl show command, if we have a look at the putty end, it looks identical, doesn't it, at this moment in time? Okay, right, bear with us. Let's go and put the other end in. So the other end, of course, was the 220 side of the connection. So we'll go and find the 220. Make sure it's talking to the right controller, which happens to be on the same node. That's the record, look, which should correspond to the body part, which it does, uni:///220. It's another 100 megabit connection, similar configuration. Set the MTU here, okay, and put it up as full duplex. MAC address has changed, as indeed as the actual IP address of that endpoint. So if we send that, authentication authorization set. Nope, let's set that first. Set it to basic and send. Otherwise you'll get a 401 unauthorized back. 200 OK. If we go and have a look at the topology, send the request. So that's a restful request going into the SDN controller. The SDN controller is then looking at its configuration. Notice how OVSDB is really active now. Everything's recorded under that record, and we can find the Uni Manager stuff underneath there as well for the EVC stuff. So we can see the 220 interface and the 225 interface. Right, just to confirm things. Let's do an ovs-vsctl. Right, now this is the difference, okay? So it actually shows here that the bridge has been established. So what I'm going to do next is I'm going to put the connection between the two. So this is another put. It's going to the SDN controller, but this time what we're doing is we're doing a Uni Manager EVC as opposed to a Uni. So the EVC number is EVC colon //1. Let's look in the body part. EVC EVC colon // 1. Those two correlate, those two match. Coming down through, we've got the source node, the destination node, and then the interfaces they're referring to, the source and destination interfaces. So that's the endpoints of the EVC. So you could be talking to two management connections on two nodes, talking about two different interfaces. Okay, good. So authorization is basic. Let's send that. Look out for the 200 OK. Happy days. Make sure it's been accepted. So I'm looking at the network configuration again, network topology. So I can see the Uni Manager has got the first interface and the second. So if I scroll a little ways back up, because the EVC stuff was at the bottom, remember, it's now sort of been elevated up. There's the EVC, EVC number 1, and it's operating between those two endpoints, 225 and 220. And the label here about the egress and ingress bandwidths that we set in the original configuration. Right, now if we have a look at that, we've actually got the GRE information. But to be honest with you, that is due to the fact that there was a little fault. If I take you back into here, look at the topology and have a send, what we can see against the endpoints, if we scroll down, if we have a look at the, what have we got here? This is the EVC, that's in there between the endpoints. And if we have a look at the configuration here, we can see 225, and in fact originally I set the MTU to 0 because I left it as it was, but in fact on the other end I'd already set it to 1500. So I went away in the background surreptitiously and removed 225. In fact, I removed the EVC and then removed 225, and then what I did is I put it back in, but with an MTU size to 1500. So then when I went, and the clue should have been straight away when I looked at Mininet, I'll bring Mininet up again. If I do an OVS show, you can see I've got the tunnel information here. But more importantly, I've also got the OVS bridge. So now I've actually got both ends in play. So both are now supporting a GRE tunnel off of an OVS bridge of OVS bridge BR0. So I can start playing with that, and I can start, investigating now that EVC. I can obviously come back and play with a little bit more as well within, setting up different parameters against that. And if we sort of refer back to the diagram, so we've got this EVC link now, EVC number 1 in play between OVS bridges 1 and 2, between those two endpoints. But before you sort of really get going, on Open Daylight we needed to make matters correct by installing the Uni Manager features. So what you could do is look to see if they're there already. So use the feature list -i through grep and see if there's anything listed there with an X against its name. If you take away the -i, so just do a feature list through grep for Uni Manager, it will list all the packages that are known to that node or Uni Manager, whether they're installed or not. And then you can go and install them using the feature install option. And I've given an example there of ODL Uni Manager -UI, which is one of the 5 packages. Then do a check to make sure it's there, and that will work. See, there is a problem in the sense that if you send RESTful commands, as we've been doing, those RESTful commands may well get to the intended node. You may well get a 200 OK back, but it doesn't actually mean it's being configured correctly. And we saw that here, because when I installed the interface and then went to interrogate Mininet, Mininet didn't have the interface. And that's because whilst the command restful had worked and was successful, and when I interrogated it, it seemed to be okay, in truth it wasn't. And this is where further investigation is required in order to make sure the service is up and running. Now if this was part of a fully fledged sort of telco type network, I'd be handing over to sort of testing diagnostics as a service in order for that to test this service and then prove to us it's actually up and running. So it's not just enough to send the RESTful commands. We also need to make sure it is indeed in play. And that's in part what we did by going down and interrogating further. So actually made sure on the nodes themselves. So in the first instance it wasn't there. It's a really good example of where you can get tied up thinking RESTful's done its job, which it has, because it's told the SDN controller, but the SDN controller then hasn't, because of a configuration mismatch or whatever it might be, configured that down onto the node. Of course, Wireshark could be of use to you, interrogating the OVSDB management messages, and then you'd read through those at your leisure in order to try and understand what was right or wrong. So what we can see here is indeed the Open Daylight controller running. It's running on the machine 220 in the 192.168.1.0 subnet. And if we have a look on Open Daylight on the SDN controller itself, so we see it's up and running here. We can see the features that have been installed just by doing a feature list. This will be quite a long list once we start playing, and quite a broad list. So it's worth expanding the screen out, sort of repeating that, and then you get an idea of what sort of packages you've got. I'm looking for an X around here. Look, you see an X there that tells me it's installed. In fact, if I do a feature list and I do a -I, then I'll just see just installed packages anyway. What I'm looking for is, I'm looking for a particular package. So I'll look for one that's installed. I'll use grep. It's my personal choice. And I'm looking for the uni manager. So let's see if we can find that. There it is. So looking at the packages that have been installed, these are the ones that you'll need to add. So we're really talking about adding this ODL-uni manager. Just need to make sure that the others are actually installed as well. The -API, the -console, the -rest, and the -UI. So make sure these are installed, and of course the command for that would just simply be the feature install and then the package name. So you'll certainly be able to see it. In fact, we'll repeat that. So that would actually take the first of those. And then just see which other elements are actually installed, or the UI, which is the one that's recommended. So if we want to have a look at what we've got, of course that's the -I variety. If we take the -I away, then we'll see all of the packages, and as we can see for the uni manager, they are all installed. Okay, so just make sure that's the case, and then you should be up and running.